Hello everyone, my name is Jing. First, let me briefly introduce my background. I went to the graduate school of Columbia University and I've been doing the software development for 8 years since I graduated. I started research on blockchain since 2017 and founded Blog Talk. We organize a lot of big blockchain conferences like this in New York City, but most of the people give me the feedback that the lecture is too difficult for them to understand. So I think it will be better for me to give you guys a blockchain 101 session first to help you catch up, considering quite a few people here do not have any blockchain background. Since the schedule is tight, I might not have any Q&A session. If you have any questions, please feel free to talk to me offline or send me an email. Okay, let's get started. To understand blockchain, we have to introduce the Bitcoin first because it's the first blockchain application. People get confused what Bitcoin really is. Somebody say it is a serial number or piece of code. Those interpretations are not very accurate. The most appropriate way to say is Bitcoin is a ledger. So what is ledger? Ledger is like an accounting system. It recorded how much money you owe and how much you own, and to whom you owe. A good example is our commercial banking system. I believe everybody here has a bank account, right? Let's say you went to groceries and buy some stuff through credit card, and your credit card will show balance of $40. After a couple of days, you pay the balance from a checking account, and then you will see the number is being deducted from your checking account. This is how the ledger works. Same thing for the Bitcoin. If you send somebody 1 Bitcoin, the ledger will record this transaction, and your wallet balance will automatically deduct this amount. So there is no physical coin here. Whole procedure is handled by the ledger magic. It's like when you buy something through credit card, there's no physical cash getting involved. It's all about the digital transaction spreading across and getting saved on some remote server. So it's all about ledger. Banking system and Bitcoin are basically the same on this point. The only difference is bank using centralized ledger, while Bitcoin is decentralized. It's easy to understand the centralized ledger. It basically means the ledger is private. Only central authority own this and do the maintenance work for all the clients, like bank. So it's all about trust. We trust bank to do this job for us. Right now, everything seems working fine. So why we need the decentralized ledger? The decentralized is the opposite of centralized. Some people believe if you hand over your money to a third-party authority, like a bank for custodian, you have to take on a counterparty default risk, since bank also possibly go bankrupt and you will lose your money. Lehman Brothers is an example. On the other hand, the leakage of your personal information is also the concern, like your ID, photo, address. Those sensitive data might be abused. So minimizing the counterparty risk and protecting your own privacy information is the motivation behind the decentralized ledger. So how do we do that? How do we make the ledger work if there is no central authority? The solution is, instead of having one central unity to control the ledger, let's make it open to public. Everybody can join and maintain this ledger as long as he has computer. This way can get rid of the central authority, and we encrypt the transaction data to protect your personal information. This is exactly what Bitcoin does. People following the same rule to collaborate and supervise each other on this ledger maintenance job. We call it as protocol. And those people are called miner. Somebody might get confused. Why it's called miner? I don't want to overcomplicate it here. To understand the role of miner, you just need to know they are simply the DB administrator. I'm not sure if anybody here has experience of database management system like Oracle SQL Server. Why DB is important here is because we need to store the ledger somewhere. This is exactly the job of DB. For the centralized ledger like bank, they use Oracle or SQL Server for DB solution. However, for decentralized ledger like Bitcoin, they use blockchain. But why we need blockchain? Why can't we use the traditional DB provider like MySQL or Oracle to keep the decentralized ledger? That's because the ledger is being shared across by multiple people, which means everybody has the read and write permission, and everybody had their own copy. So the things getting very tricky upon the synchronization of ledger. Let's see a very simple example. Peter's wallet has total balance of 1 Bitcoin. There are two distinct transactions from different versions of ledger. One is sending the Bitcoin to Alice. The other is sending the Bitcoin to John. Both of them are considered as a legitimate transaction. If there is a new guy coming and he says, hey, give me the latest ledger, now this poor guy is facing two choices and he is not able to make the decision. This is called a Byzantine general problem. All the distributed system will face the Byzantine general problem. It is very challenging from a technical perspective because you cannot assume everybody is honest. Someone might be cheating and try to sabotage the transaction data, and the ledger will be screwed. So we need a good protocol to make sure there's only one golden copy for people to synchronize. This is why blockchain comes into the picture. The creation of blockchain is to solve the Byzantine general problem. So how does the blockchain work? First, we're going to create an empty space. We call it as block. And all transactions are stored in block. But in the meantime, we also set the limitation of this block space. Let's say one block can only take 1,000 transactions maximally. We pack them up and put it into an encryption method as input. It generates a random serial number. Suppose it's ABCDE. We call this as hash. Hash is like a unique identifier for block. Any block is searchable by the hash. But one block is not enough here since we will have more incoming transactions. So for the next block, we did a similar exercise, except we introduced a hash pointer which can link to the previous block. Like this. This hash pointer will be encrypted together with transactions to generate a new block hash, let's say it's CBFGH. And we keep doing this exercise for next block, so on and so forth. It's like a chain structure. This is where blockchain get a name from. The reason we use the chain structure is to enforce the data integrity to prevent historical transaction being tampered. Suppose some bad guy want to hack the ledger and modify some transaction data. According to the encryption process, the corresponding block hash will be changed because the input has been changed. Once the hash changed, the linkage will be broken. Then we have enough reason to invalidate this ledger copy. But here is another problem. It's not difficult for that hacker to fix the issue. If he want to keep fooling you, he will fix the following blocks by replacing the new hash pointer to make sure the linkage is established again. It's called a grinding attack. In order to handle this problem, we need to add more challenge against the hash generation process. For example, we can introduce a threshold on the hash output. Let's say the hash output have to start from 00. That means only a certain range of hash will be considered legitimate. Since the output is totally random, people have to brute forcefully try the encryption method many times until get a valid hash. This process is called mining. Then things will become totally different. Now creating a block has a certain computation cost, and hacking the data will also incur the cost, and sometimes the cost is even bigger because you need to redo the mining process to fix the broken link, as I just showed you in the last slide. That makes the bad guy lag behind on the block creation, and his chain length is smaller. Then it is very easy for us to make a decision. If there are different ledger copies, we just need to pick the one having the longest chain, as long as the good people own the majority of the computation power. We can confirm the good ledger having the longest chain, and thus our system is safe. This process is like voting. Just like the votes is counted by computation power, there is certain reason why we do the voting like this, instead of voting by the other criteria, like number of IP address. It's simply because computation power cannot be forged. But the IP can be created with zero cost. Now we understand the motivation of decentralized ledger and how blockchain help to keep the ledger safe. But blockchain is not only for decentralization. Actually, based on a certain use case, we can add different permission level for people to maintain the ledger. The permission level here means how selective we pick the miner. In some cases, people need to be authorized to access the ledger. Based on different permission level, we have three types of blockchain: public chain, consortium chain, and private chain. Public chain means the ledger is fully open to public. Everybody can be the miner. Like Bitcoin and Ethereum, consortium chain is more selective on the miner. Some company or organization will work together and form a consortium. This consortium will determine who get the right to maintain ledger. Example like Facebook Libra and New Power, which is an energy blockchain project, will be introduced in next presentation. Private chain is most restrictive. That means the ledger is totally private. Nobody from outside will get the access. This will also be considered as centralized ledger. Some example like JP Morgan coin and the digital currency from Central Bank of China, those are private chain. Some people might ask question, wait a minute, you were saying Bitcoin is a decentralized ledger, which is used to totally get rid of the central authority like bank or government. And the blockchain is a technology stack to support this decentralized infrastructure. But why the central authority like JP Morgan, Chinese government, or Facebook start to use blockchain? This is what a lot of people get confused here. If government decentralize themselves, there will be no government. If Facebook decentralizes itself, there will be no Facebook. Actually, the bank and the government are not interested in decentralization at all. The reason why they are using blockchain is because of its side product, token economy. Token economy basically is redefine a new transaction protocol which uses a virtual token for circulation. So what is the benefit here? Nowadays, every trade in the financial market is not directly peer-to-peer. It has to go through a third party first for clearing, which is called clearinghouse. I'm not quite sure if anybody here trading stock. Let's say you buy 10 shares of Apple on brokerage account and after several days you cash them out, but you will not get a fund immediately. Even if you see the number get changed on your account, you are not allowed to move this fund to your other account until you wait for 7 business days. This is because those trades are not settled and it need to go to the clearinghouse first, and this step is not for free. They will charge you money on doing this. Over 50% of the total transaction cost is coming from the clearinghouse. DTCC, ICE is the biggest clearinghouse in US. They are dominating this market. Let's say even 1% they charge on transaction costs. There are trillions of transactions every year which at least will cost you billions of dollars. It's a big money. This is why blockchain's token economy comes to the picture. Because it can totally get rid of clearing. As long as the transactions has been recorded on blockchain, it will be considered as settled. This is cool, right? Thanks to the UTXO transaction model, we can make this happen. This model is easy to understand. Any transaction contains a set of input and output from which you can link to another transaction. So it gives you all the clear picture of how the money gets circulated, which makes sure each fund is traceable. This is quite a good feature bank or government like about. In one hand, it saves a lot of cost from clearing. On the other hand, it introduced the fully transparency. This is why JP Morgan, Libra, Central Bank of China all want to do this blockchain project. Besides the transaction cost saving and transparency of trade, the token economy also has the other benefit. For example, we can introduce more metadata into the token itself to facilitate the digital ownership of some physical property like real estate. In this way, we can transform the ownership exchange to the token trading, which largely increase the liquidity on a secondary market. This is motivation of the security token, which will be introduced later in one of our keynote sessions. That's all from my side. This is a beginner class which I hope it will get you understand blockchain. I know blockchain is complicated and include more details. I cannot cover them in one session. For more details, you can follow my WeChat subscription, and I also welcome you to send me email or chat offline if you have any questions. Thank you.